Um, we have discussed about the significance of automation, significance of computerization of the objects, and the coursework which are offering at various places, including our center, Wellanking. So we have discussed about the what is machine, what is types of machines, and what do you mean by smartness, and these applications of the machines, particularly what we call as the robots. And we have seen that what are the learning outcomes of these courses and some examples we have discussed and the types of robots. We have divided this course into three parts as we have discussed. One is level 1. We start with introducing the basic components, soldering, testing, troubleshooting. Level 2 is some programming skills. We are starting with user-based graphics, user-based programming, and various levels of programming, and then applications of those robots, small tiny robots. So today we will discuss about what are the professional courses, professional skills we are offering at this place. We, to begin with, as said, the course 1, we wish you should learn about what do you mean by computer, computerization, what is the importance of the programming. Since it is the level 1 course, beginner's course in programming, we feel you should know about a robotics programming using graphical user interface, what is called QU robot. Once you are comfortable using the computer interface, programming the hardware, assembling the hardware, applications of the hardware, then we will go to next skills, that is called level 2 course. Level 2 course is introducing various sensors which are called interfaces, various peripherals, and then the programming board this time is you only fabricating, even soldering to fabrication one has to do that because we have specially designed for learning purpose. This is what we called as a EduRobo. However, the programming won't be using graphical user interface. It is a true sense of programming by what is called embedded C language. The compiler you will be using is Arduino compiler. This is our level 2 programming course. Level 3, we feel one should know what is computer, what is IBM computer, what is the role of Intel, what is the role of IBM, what is the role of Microsoft in building the computer, and what are the parts of the computer in terms of hardware as well as software. Assembling, deassembling, installation, some extent few troubleshooting tips is what you will be learning in computer hardware. Then the software part. How do you load the operating system when you newly install, when you newly assemble the computer? How do you partition the hard disk? How do you make them as a logical drives? Then how do you load the operating system? And some tools, Microsoft tools, some compilers, how do you install them? And the basic configuration of the computer. That is the fourth course. The fifth course is Today, 70% of the jobs are in service sector. So you need to service the customer. So how do you demonstrate your product? How do you communicate to them? Right? Is all about one, of course, subject, but then about the personality, your communication, presentation, and some technical skills. So it is very important to know about presentation, communication, writing skills. What we call as a soft skills. So that is the fifth course one should practice. Even the professionals, even the higher education, after doing higher education also, people do have problem in presentation, communication, and technical skills. When it comes to the last course, some companies like Microsoft, Linux, Mac, they have developed some documentation tools like Word file, Excel file, PPT file for writing or data entry, analysis, and presentation. So these are the tools undoubtedly lifelong one has to go through it, the minimum skills. We feel these are called professional skills. One should learn about it. Time to time, these recorded my videos I am posting on the YouTube. You can one can go through it, replay it, practice it, finally do it yourself. We also give some awards or we also charge some minimum amount, whatever. All these things happens through transparent manner. So you can refer our online statements. All right, so let's discuss now in this session about types of programming. We already discussed about the importance of these programming skills, professional skills, soft skills. Since this center, Wellanki Center, we have developed, we have invested, but the purpose of this center is students should maximum utilize it. However, as you know, even after investing crores of rupees, we are not charging anything from the students except the cost of few logistics, minimum expenditure. So CC, this is as good as self-service. The center is majorly for two purposes. One is the people who wish to come here, stay here, understanding the the purpose of the life, meditation, peacefulness, wish to stay here. That is what we call meditation. Meditation is not any spiritual thing, not religious thing. It's a spiritual thing. One can no prayers, nothing, just practicing some meditation skills. Second is about skills, which we would like to give it to the young students. As I already mentioned, few modules which we are offering. It is also for the students who are studying higher education institutes where they have some internship programs for short term and long term internship programs. So since it is self service based center, no commercialization or commercial activities, the maintenance, the cleanliness, fresh rooms, living rooms, halls, everything should be clean and neat. As and when you get time, at least every day, we expect half an hour to 1 hour, you should give the service to the center. So we believe cleanliness is next to the godliness. Since you are also having some skills in you, maybe painting, right, or some other cultural related things, or gardening, farming, please do contribute in beautifying the center. So this is self motivation. We don't force you, we don't fine you, but we expect you voluntarily. We do contribute in bringing the center, the best of the center, at least in terms of maintenance and maybe showcasing our culture. All right, so in this session, before we talk about the types of programming languages, let's once again compare the difference between human and computer. Why we are comparing? The reason is we are always talking about whatever the human is doing, we wish that the in our day-to-day life, whichever is the machines we are using, we expect the machines to do the same job. This is what I explained in the first video. Today we named that called artificial intelligence. Humans have natural intelligence and we wish the machine should do the thing artificially. So now, so since you want to make a machine like a human behavior, so what a human is having some inputs, some outputs, right? Like inputs means you take some outside information to your computational unit. Who is your computational unit? Brain. Finally, whatever is the data you are collecting, who is processing is your brain. Entire body is getting the signals from the brain. If the brain makes non-functional, then it won't give any commands to the rest of the body. That's what we call as a paralysis. So if the inputs like eye, nose, tongue, ear, skin, if these inputs have any problem, if any one of the input is not functioning, then we call as a disabled person, learning disabled. Today we call as a learning disabled person because the data that person is not getting. So in short, what we call as a sensors. So if one of the sensor is not working in a human, then we call it as a disabled because his smartness is coming down. So the person has some difficulty in understanding the things. Or we can say the intelligence level is coming down. What are the outputs for a human is mouth, finger, hand, legs. These are the physical movements where he or she will express, do the things. But in other language, we call it as a actuators, enunciators, and so on. So since we want these things to happen by a machine, what the machine is having inputs, keyboard, mouse, right, pen drives, floppy disk, hard disk, or joysticks. These are all inputs to a computer. Or we also have, now today, we have some other ways of feeding the data called scanners. There are inputs. What are the outputs? Monitor, speaker, printer. What is the computational unit? Brain is the CPU. Equivalent to a brain is a CPU. Otherwise, memory, we have storage here also called semiconductor memory and the hard disk, equivalent to a memory. Like we store the information in our memory, computer also store the some information in the memory. Humans also sometimes lost the data, they don't remember. Computer also has some data which is lost, called RAM. The program which is permanently stored is called ROM, or we today we also called as a flash memory. Same thing happens in the humans also. There are some data programs which are remembered, some data is lost for over a period of time. So whatever, we are always trying to make a equivalent of a human, a machine. That's what is called computer. How smart is the person, that depends on how much amount of data is having, how much amount of analysis he is doing on the data, right? When a newly born kid is having all these parts, whatever so far I said, but the small kid is not intelligent because the amount of data is not sufficient. He is still learning, right? He first teacher is the mother. The mother will introduce everything, and that kid will store the data, remember, analyze, and next time will recognize, take some decisions. Slowly, 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 the kid will reach to a stage where the kid also will start taking decision on their own. So that means analysis comes into picture. When the intelligence will be there, when the kid also has some self-learning abilities, and then a lot of data is acquired because of this learning abilities, and then is a beyond the amount of database the kid is having or a human is having is much more than an average person because of the learning, the amount of data he has gathered. And naturally, when he do the semantics, the analysis, it will be much, much better than a average person. That's where we call it as a intelligence or smartness. If the data itself is small, like for example, if you don't study for the exams, if you quickly read few pages, the entire semester, if you don't read it, then you have very less data. Naturally, when you want to write something, when you want to suggest something, it is limited, right? So that's where it makes the difference. So everything to do with the amount of data you have gathered and the analysis part. That's what we call as a intelligence. The same thing is applicable to the machine computer also. So as far as the working is concerned, humans also require food for energy to convert into energy. Same thing, the computer also requires some energy where we give the power, electricity. Whatever is the power we give is a AC power to a power supply. Internally, it converts that AC power into DC power. And finally, the amount of power the computer uses is few watts to maybe around 500 to 600 watts. The voltage, in terms of voltage, the DC voltage may be as low as 5 volts to 3.3 volts, 2.5 volts, 1.2 volts is the operating voltage of these electronic components. There are some components which also require higher voltages, like drives, hard disk, it requires 12 volts. So when I am talking about the intelligence, smartness, means the computational power, right? How many instructions I can execute, how much amount of data I can process, right? That's all depends on the power of the CPU. Like I compared a small kid to a average kid and a maybe higher standard kid. If you compare, the capacity to take a decision is not same. It grows, right? So same thing is applicable in computer. We have some CPUs, right? Central processing unit, brain of the computer, which is called single CPU, called single core. Means only one CPU is there. We have CPUs which is called dual core. That means two CPUs are there. Quad core, four CPUs are there. Hexa core, six are there. Octa, eight is there. Deca, 10 is there. So these CPUs physically they are not visible. Physically they look like as if it is only one chip, but inside the chip it has many CPUs, what we call as a core. Hence repetition same architecture multiple times, because day by day the when your demand for executing more and more instructions are increasing, right? Then one CPU is unable to do it. So they're deploying more and more CPUs inside the chip. So more memory, more CPUs will help in executing the larger programs, and huge amount of data is equivalent to a smart human being. So today the CPU, the memory has reached to a stage where it is operating in around 4 gigahertz speed. 4 giga, right? Right? Mega is 10 to the power of 9, giga is 10 to the power of 12. So 10 to the power of 12 is the operating speed, the amount of time it takes to execute one cycle of a instruction. And how much amount of memory we are able to store in the computer is gigabytes, terabytes, right? Again, G means to the power of 12, tera to like that. And always in terms of to the kilobytes, megabytes, gigabytes. Today we have reached to the terabytes. So the CPU today is not working on kilohertz or megahertz. It has gone to gigahertz. The memory storage capacity is not kilobytes or megabytes. It has gone to gigabytes. So there it is gigahertz. Sorry, here it is a terabytes. Like I said, when it comes to computer, three things are important: the CPU, the memory, and the software operating system. The are the programs which is executing instructions, which are executing on a given set of data. How the computer works. In a computer, like I said, you have inputs, you have outputs, you have processing inside a CPU, and you have a storage. What are the inputs to a computer? Now, same thing you compare with a human being, like keyboard, mouse, microphone, scanner, cameras, sensors. This is how we give the input. Means by using these devices, the external world information we feed to the system. That means the data. But the data is not small. The data, we cannot store it inside the CPU. So we have a separate device called data storage. The data storage is also different types. Some data is permanently stored. Some data is temporarily stored. Some data is stored in a semiconductor devices. Some data is stored in a magnetic storage devices, or some data is optically also it is stored. So data is always stored not in the CPU, in the memory. So we need to understand here two things. Program is different, data is different. What is a program? Program means set of instructions. What is a instruction? Instruction is a command. What does the command do? Behavior of the CPU changes, right? For example, if you give one command, it will behave X. If you give second command, it will behave you differently. Let's say, for example, you have given a command print, then it will print it. When you say scan, then it will read it. So everything is a command. Command means instruction. But what is data? Data is different. Data means information. So, for example, you are measuring the temperature. So the temperature every minute, every second is changing. That value is a data that we feed it. But you take a decision. If the temperature is more, switch on the air conditioner. If temperature is less, switch off the air conditioner. That is an instruction. But the value, the temperature, when you measure it, it is a data. So I hope now it's clear to you that program is stored in the program memory, data is stored in the data memory. As you write a big programs, powerful programs, then it will become more and more smart, intelligent. But to make it intelligent, you also require good amount of data because finally the decision is taken based on the amount of data which you are storing. And the other device in the computer is called output. What the output is doing? Exactly opposite. Means it is converting whatever is the information which is having stored in the computer back to the outside world where a, anybody can understand. So it may be print on a printer, it will display on a monitor, it will convert into audio form by using speakers or through plotters, it will plot it through graphically and so on. So I hope now you can understand that we started comparing with a human being, then we started understanding what do you mean by smartness in a system, in a computer, what are the basic parts of the computer, and what are the basic functional blocks in a computer. So since the this course, first course, we, we want to discuss about what do you mean by programming. Programming, like I was saying, is a set of instructions which are like a commands. So how do you give a command to a brain, right? Finally, it is a CPU is a brain. You need to tell the brain do this job. So that's a command. So how do you give the command? What is the easiest way where a human can give a command to the computer? Today we have seen even by speaking also we are giving commands like Alexa devices. So Amazon has developed some products, Google has developed some products, Microsoft has developed some products where we don't need to feed any program through audio, through microphone, where we give some commands. That command, that audio signal is converted into some another form, and it is doing the job of, for example, playing some music, switching on some lights, and so on. So we have reached to a stage where what is called natural language processing. A human can speak naturally, and a computer also understands the language naturally. So natural language communication, normal language. Though we are using English, but very soon it could be Telugu also, it could be Tamil also, could be Hindi also, it could be any other language. Today we have language translators. We don't need any human to convert one language to another language, where some softwares are doing this job. So that we are trying to put it in a device called computerization of the object. All right, so I hope it is clear to you what do you mean by programming, commands, command-based programming through natural language. We also seen some devices also works on vision. They recognize our face, they recognize our iris, they recognize our gesture. So by moving the hand, moving the head, expressions also, some of the devices computers are working. So facial expressions, image processing also has become a programming language or commands we are giving to the computers or the devices, computerization of the devices. This is the level, today level. Very soon, even you don't need to speak, you didn't need to express, you only has to think, right? Today, some of the computers people are developing in such a way that you just think, your brain waves, you are thinking, and that thinking can is converted into a command. Very soon such type of machines also will be available in the market. Some companies have already started developing these products. You have to capture your brain waves. Okay, anyhow, but this is a higher side. What we are talking today, at least in this course, is the not smart devices, but closer to that is called some programming, by where we can write a set of instructions. So what are those set of instructions? So what is the process of writing the set of instructions? What we do is, first we write on a piece of paper what is called algorithm or a flow chart, that what is that I want to do, what is that I want to implement. So I will write it maybe in Telugu, Hindi, Tamil, whatever you write on in your own language. This is what I want this device to implement. What we call as a program. This program you can also, instead of writing in a script, you can also write it through diagrammatically, what is called as a flow diagram. Like in this slide, you can see there is a flow diagram saying that how to start means just think starting point, from where to start. Once it starts, then one instruction after another it has to process. So you write a program by using some editor. You say take some editor. For example, today we have Microsoft Word, Notepad. So such type of editors also there. So every programming language has some editor where you can type it, you can delete it, you can copy it, you can paste it, you can save it, you can rename it, right? You can replace it. So these are called editor functions. Use some editor, type the program, save it. When you save it, definitely it will ask you what is the name of the file. Not only that, extension. Every file has some attributes. So that attributes you have to specify. So sometimes we say dot text, sometimes we say dot doc, sometimes dot say we say PPT, sometimes we say dot C, and so on. So whatever is the uh, software you are using, what we call as a compiler, as per the compiler's requirement, we are supposed to save in the same format only. So after that, what the compiler does, it will convert whatever you have written line by line into some another form. Because whatever you write is a language where you understand. However, the computer, means the CPU, doesn't understand any other languages except one single language called machine language. Machine language means it understands only a binary number system, means 0 or 1. It understands only two numbers, 0 or 1. Means the complete information so far, whatever I am talking, right? The knowledge, whatever I am talking, the outside world, whatever the sensors, we talked about smell, we talked about vision, we talked about audio, whatever you are talking, finally you have to store in zeros and ones form only, where a CPU can understand. Why zeros and ones? Because when you talk about a CPU, when you talk about a memory, these are all called digital systems. Digital system means only two digits. The number a digital system understands is only two states, either zero state or one state, either low state or high state. Only two states. In electronics, zero means 0 volts, one means, let's say, 3.3 volts. If your CPU is working on 3.3 volts, that means high state means 3.3 volts. That means your entire system, right? That electronic system, CPU, memory, sensors, peripherals, all of them are working on 3.3 volts. So it understands only two states, either yes or no, either 0 or 1, either high state or low state. So computers are digital systems. A digital systems understands only two states, 0 or 1. However, when you want to write a program, your program, if you want to write in zeros and ones, say for example, I want to do some job like print the data. I want to play some music. I want to play some video. So then you are supposed to write some program for that. See, look at the variation. Every topic, every command has a different nature of things. How do you represent those things by using zeros and ones? It is very difficult. When you have millions and billions of commands to do every day, to differentiate between one command and another command, you should have some difference. And that difference, if you are representing by zeros and ones, it is very difficult to remember. For example, do you remember your mobile number? How many mobile numbers you remember? Do you remember all your friends' mobile number, your parents' mobile numbers? Do you remember your vehicle registration numbers? How many vehicles you are having? Do you remember all the numbers? Do you remember your Aadhaar number, PAN number, and bank account number? When day by day, when these digits are increasing, and when passwords for that matter, so many passwords have come up. So it's very difficult to remember these passwords. But what people are doing now, okay, now let's not have passwords. Let us have some voice commands or fingerprint recognition, iris recognition for authentication. But you need to understand one thing. Even if you put a finger, even if iris scanning is done, finally this is converted back to zeros and ones only. because the system is made up of digital. A digital means binary, binary means 0 or 1. All right, anyhow. So programming languages may be different, but then finally they are converted into zeros and ones. So that is the role of a compiler. A compiler will replace your program with zeros and ones. A CPU can understand. But here you have a problem. While typing the program, you may type some mistakes, what is called typematic mistakes. This typematic mistakes means what? Grammatical mistakes. For example, when you construct a sentence in any language, Telugu, Hindi, English, there is a format. In that format, if you don't write it, then you know your teacher, your language teacher says that this sentence is not correct. You didn't put space, you didn't put full stop, you didn't put comma, or the verbs or the sentences. They always say that this is not a correct representation of a word or a sentence or a paragraph or a document. That's what I also said about technical writing. Writing is also has some standard. Same thing happens in program. Unless you type your program in that particular form only, standard only, it is going to be error to the compiler. Because the job of the compiler is to replace your instruction into a binary form. But if you don't type it properly, if you don't put proper commands, proper style, then it says that I don't understand this, what you have typed. That's called compilation errors. As long as compilation errors are there, it won't generate a output file. It will always throw some errors on your computer screen and say that I am sorry, I am unable to convert your program into a binary language, output file, machine understandable language. So that's why again now this fellow is going back, right? As you can see, compiler is again going back saying that please so and so lines have some problem, please rectify it. So this is a complete process of closed loop system. You write something, it will compile, and then it will find out, it will give it back to you saying that some problems are there, so and so lines have errors, rectify it. So if all lines are typed properly, then only it will convert, it will come out saying that since there is no compilation errors are there, take the output file, which is called program output. The program output is in binary language, zeros and ones. No symbolic representation, no other language type of commands, only one language called zeros and ones. So you can test that program by executing. Executing means what? Now the CPU understands these commands because it is in zeros and ones. It will try to implement that. But how will you come to know that it is doing properly its job? You said, right, switch on a lamp. So is it switching on? Yes or no? No. But it's not a compilation error. It's a behavior is different. It's not doing that job. But compilation is done, but still it's not happening. So that means it's not a syntax error. It's not a typematic mistake. It's a logical error. What is logical error? Logical error means your language is correct. Absolutely no problem. But like we say, no, operation is done, but patient is dead. Means you have successfully performed the operation, everything is done, but patient is dead. Or let's say you have done everything, nice cooking and all, everything is fine, but the food is not tasty. What you thought, right? You put all the ingredients, everything is there, but finally when you serve it, the customer says that not satisfactory. So that is called logical. Logical means what you expect, you are not getting. So there is a problem since logically what you do, again you try to add some salt or add some sugar, something, no, some ingredients, and you rectify it. And then finally you again change the program, compile the program, run the program. Once you get the desired results, yes, bulb is on, yes, food is tasty, yes, printing is done. So then is a termination. The whole process is completed. This is what is the complete process, programming process for a computer or computerization of the objects, means devices, robotics. So let us look at the programming levels. The bottommost thing who understands is a hardware, CPU, right? It is a semiconductor device, hardware. This fellow, right? Hardware means semiconductor device, integrated circuit IC, which understands the program. On top of it, but CPU, as I said, today we are talking about digital systems where a CPU, a semiconductor device, is made up of a transistor. A transistor has only two states, either high state or low state. So naturally, your language also has to be only two states, either low state or high state, called machine language. Machine language means binary, 0 or 1. On top of it, since it is slightly difficult to remember zeros and ones, right? The binary, the numbering system, like I told you, your vehicle numbers, your Aadhaar numbers, your bank account numbers, is very difficult. So since binary is a language difficult to remember all sorts of combinations, commands, people have developed a language called assembly language on top of it. Assembly is slightly better. At least I have used 20 years assembly language from 1995, almost from 85 to I would say 2006. I have used these many years. Even today also we use undoubtedly. But I am saying assembly is the reasonably a better language. People have used 30, 40 years. However, assembly language also slightly difficult because today we have reached to a state where our programming is in millions of instructions, not 100 instructions or 1,000 instructions. We want the computer robots to behave like a human. Then imagine how many lines of code you have to write is not even hundreds and thousands. It is in millions and billions of instructions. Then only you can say artificially intelligent, equivalent to a human brain. So it is very difficult to write even the programming in assembly language. What is assembly language? Assembly language is a set of commands, some symbolic representation, and some looks like English words like addition, subtraction, multiplication, division, move, store, like these English verbs, English words, you can use it in the programming language. But again, these are also, since so many are there, 200, 300, 500, such kind of instructions are there. And when you write the program, it's it has gone to millions of instructions. Modifying the program, remembering the program, documenting the program, upgrading the program is very difficult in assembly language. So that's the reason now even we had gone next level of programming called high level language. What is high level language? High level language means It is nothing to do with the hardware. As you can see, we have reached up to the third state where, like your normal language, right? You can write, for example, we are using English, but Chinese doesn't use English. They write the program in Chinese. Germans write in German. Russians write in Russian. We are not, we are still, since we are still continued the Britishers language in English. But otherwise, we would have used Telugu also, Hindi also, Tamil also, and so on. Anyhow, we are still using English as a high level language. So, how a high level language looks like normal language, the way we speak, the same thing we write in the program, right? Say, do, stop, run, like that, normal, a human language. That is high level language. In high level language, people have developed the name of the language is called Fortran, C, Pascal, and like that. Even that has gone to one level above called visual language. So, in this course, the first course when I am teaching to you all, I am teaching visual language, highest level in the programming languages, right? So, what is visual language? Visual language means even you don't need to write a simple spoken English, right? The day to day, whatever we use spoken English, also you don't need to write. You, it's a graphically, right? Like a boxes, right? Code blocks. You take some block, you put it into your compiler, and then that's all. That block, for example, addition is a block, subtraction is a block, right? Multiplication is a block. So you don't need to write, type something. Like in schools, right? We children build some uh, objects, right? What is called joining the blocks. So here also we join the blocks and to construct the toy or something, some devices. So now look at the paradigm. What is the topmost language is a visual language. Next level is high level language. Next is assembly language. Next is machine language. Finally, it goes to hardware. But please remember, whichever maybe you may be, if I'm machine language, very good, closer to hardware. If you are writing in assembly language is converted into machine language will go to hardware. If you are writing in high level language is converted into assembly language converted to machine language goes to the hardware. If you are writing in visual language, graphics, then that graph, whatever the blocks you have drawn, those blocks, those graphs are converted into high level language. High level language converted to assembly language. Assembly language converted to machine language. Finally, it goes to hardware. So, in short, please understand when you write any program, whichever may be the language you use it, finally it is converted into machine language called zeros and ones. So always remember lifelong, this is how a digital system, a CPU, a memory is a semiconductor device made up of transistors. A transistor has only two states, low state and high state. And you can use any language, but they understand only zeros and ones. So finally, it has to come down to a transistor which understands 0 or 1. Okay, so like I already classified types of computer languages called low level languages, medium level languages, and the specialized languages. We have over a period of time, based on amount of time you can write the programs, but we are not doing binary type of language, assembly language of programming, though we can do that because today people are asking, demanding high level languages, not the low level languages. But then, since in this course, it is a beginner course, you should be familiar with what is hardware, what is robotics, what is IoT, what is computerization of the objects, what in by application specific systems. These are all not computer writing the programs other than computer, and a huge demand is there. Billions of devices is being manufactured every day. Thousands of applications are developed almost every year. That's the reason you need to understand why writing the programs for other than computer is important. So let us start with the easiest language, highest language, and slowly we'll come to the medium level language. If you are interested, we can also teach you the low level language. Already said the numbering system. Why we are talking about the lowest level is binary, because it's made up of transistor. A transistor can understand either low state or high state, 0 or 1. But however, being a human, it's very difficult to remember these combinations of binary. We prefer octal numbers, hexa numbers, ASCII numbers. On top of it, as I said, mnemonics, assembly language, or high level language, or graphical visualization. Day by day, we are making more closer to the human's natural way of communication. Okay, I already said how a assembly language looks like. As you can see, it is a symbolic representation, what we call as a mnemonics. And this mnemonic consists of what is called opcode and operands. Opcode is the behavior, operand is the data. And this fellow, if you write it in assembly language, assembler will convert this language into binary, machine understandable code called zeros and ones. So in short, finally a CPU understands only zeros and ones. You may type it in assembler, you may type it in a high level languages. So a high level language, you can see how it looks like. You say triangle, you say surface, you say square, you say sine, a normal mathematical symbols. For example, you say multiplication, functions, operators, conditional statements. So you have little bit of like understanding, easy day-to-day language. However, documentation point of view, typing the program point of view, it is very easy to teach this language because it's a natural language. Every day we communicate, we document. But then a CPU doesn't understand this. So a high level language is converted to low level language. A low level language is converted to binary executable file format. But in this course, today's course, I am talking about visual programming language, what is called code blocks. A code block, now you can see here, no assembly language, no high level language, no binary language. What you have, whatever so far you said, the commands, operators, conditional statements, everything is a block. Okay. So whatever is the command you want to use it, select that block, put it here, select that block. This is like I told you, joining the blocks to construct this thing, code blocks. Or some people also draw the figures. You draw some figure, I want to do this, is converted into code blocks. Code blocks is converted to high level language. High level language is converted to low level. So we are in this course, we have some robot which understand, I mean, not the robot, sorry, the language is based on code blocks, visual programming language. So we'll write the programs. I will teach you in the next session how to write the program. We'll write the program in this language, and that is converted finally into binary language. Okay. So We already discussed about the computational devices, a IC integrated circuit, which is made up of semiconductor materials. But there also they have classified into three categories called FPGA and CPLDs, microprocessors and microcontrollers, and ASICs. Where do you see these CPUs, computational devices? Microprocessor is you always see in computer. So the brain inside the computer, CPU, is always called microprocessor. However, when you are using, let's say for example, your pen drive, is also have some semiconductor device. You are also have some washing machines. You have air conditioners. You have refrigerators. You have robotics applications. They're all using microcontrollers, not microprocessors, because there is a slight difference is there. That computer CPU is having different kind of a requirement. All these applications are having a different kind of requirement. So computer uses called general purpose CPU. But however, other than computer, wherever you see the CPU, they are application specific. So they are called microcontrollers. For example, your calculator. When you open a calculator, you don't find any external memory, right? External peripherals, just one chip you will find. That's all. That's why they prefer microcontrollers, not in microprocessors. However, in computer, CPU is different, memory is different, input is different, output is different, everything is different. So that's why microprocessors are used in computer because CPU job is only execute a program, not to store the data and so on. FPGAs and CPLDs are also computational units, but they are generally not used in public domain. They are used for scientific applications like defense, space, right? Some applications where performance, security is at most important. So this language itself is altogether different. Whatever today we are using, they are not the languages. The languages for these CPUs are called hardware description language, which is altogether comes under, there is a subject called VLSI design. So there people use those languages. The third category of CPUs called ASICs, application specific integrated circuits. ASICs means there is no language, right? You cannot write a program. The manufacturer of the chip only can write the program. While making the IC, he will put the code inside the chip and manufacture it. You cannot modify it. Lifelong, you have to use the same program. Where do you find the application, such kind of chips, such kind of CPUs? Let's say calling bell. In a calling bell, when you press a button, it will play some song. It will say play some music. But that song, music, right, is also a data. And to execute the data, to convert the data into analog signal waveform, it requires some program. But lifelong, that program, lifelong that data, you are not going to modify in the calling bell. So that means you do not want any program which is going to be modified. So that is why they don't give a choice to the user to change the song to upgrade the program. The factory only, they put the program, they put the data and will sell it. That is called ASIC. So a calling bell is a ASIC. Similarly, you will find so many applications where lifelong you cannot modify either the program or data. Such kind of products, for example, toys, children's toys, or Deepavali lamps, the smart, right, lamps, like that. These are all the low cost products where use it and throw it, no upgradability. Such kind of CPUs are used by technology called ASIC, where the program and data is done while manufacturing that semiconductor device. I hope now it is clear to you what are the types of CPUs called computational units or we also compared with the human brain. However, all brains are not same. It based on your application. Do you want a CPU for computer, or do you want to have a CPU for like applications like microwave ovens, air conditioners, refrigerators, mobile phones, robots? They are called microcontrollers. But there are some applications like ATM machines, defense applications, nuclear power reactors, space applications, where secrecy, confidentiality, security is at most important, including performance. There they prefer FPGAs and CPLDs. Third category is no upgradability, no modification, lifelong, it should be same, but low cost. They're called ASICs. There we use CPU called ASIC. So in this course of robotics, I hope now it is clear to you. In IoT and robotics, most of the applications, 99% cases, we use microcontrollers because microprocessors are used only in computers, nowhere else. That is why we always compare microprocessor with other CPUs because microprocessor is there only in CPU, in computer. Which company we use? Only Intel. What is the number today we use? The CPU number i3, i5, i7 or i9. That's all. However, how many microcontrollers are there in the market for all these products? Thousands of microcontrollers are there because every application, calculator CPU is different, mobile CPU is different, refrigerator CPU is different, air conditioner CPU is different, robotics, thousands of robots are there. We have discussed in the last lecture. Every CPU is different. So that's why they are called microcontrollers. So that is the beauty of this topic. We will discuss again that what is microcontrollers, maybe in other subject. But whatever is the programming we are doing in this entire course on microcontrollers, that's why we call this as a application specific programming, because you have to choose a target. Which is the target? Not Intel, not i3, i5, i7. It is something else. So we have to choose a target and then write the program. That's the beauty of this course. Huge potential demand is there in this area. So I told you, I compared. Why we always compare human being with a computer is because both of them are standard things, right? You go anywhere in the world, human structure, human DNA is same, entire world. Similarly, you look at the computer anywhere in the world, you go see the computer anywhere in the world, even if you go to China, Russia, Germany, or these European countries, the computer is same. So that is called standard system. Both are same. However, when I am talking about robotics or IoT applications, they are not standard. Every product is a customized product. So that's why we are training the students, conducting these training programs, because you have to design a product based on the application. You cannot put a computer in traffic lights. You cannot put a computer in the human body. You cannot put a computer in your mobile phone. So its computer is not in demand. What is demand is computerization of the objects. That's why in the entire session I was telling it's not about computer. It is computerization, means we need to make that system behave like a computer. But the components are not computer components. It is something else. However, again, software and hardware. So language is same, but application specific. So since we have several applications, different applications, so we need to understand any application. Always said that when we compared with a human being, I said that we have some sensors, right? The sensors are giving the information, and then we process that on the information. So they we called as a signals. Where these signals are coming from? For example, since being a science student, I'm sure every kid, everybody understands biological signals. a human body generates these signals, right? Your heart generates a signal called ECG signal, electrocardiogram. This is how the signal looks like, heart generated signal. PQRST waveform. You look at the beauty of this waveform. It's not a straight line. If it is a straight line, then you are a dead person. It's not a straight line. It has some P wave, then Q is going down, then R is going up, shooted up. S is going below Q wave. Again, T is slightly higher than P waveform, and it has some duration. It has some amplitude. So the behavior of your heart valves, heart pumping of the blood is represented by this waveform. That's why every doctor would like to see how your heart is functioning by grabbing the signal. So what we require is a sensor which will capture this signal and will print that signal on some piece of paper, or at least display it on some display unit. So this is our job, that, oh, every heart is generating a signal. I am supposed to sense it, convert it, display it, print it. That's what is our job, signal processing. We will be doing extensively in future, not immediately, but maybe higher levels of the training programs. Even in a potato also, if you put some these things, electrodes, it will give you some potential, some voltage. It will generate potential difference. If there is a potential difference is there, then current will flow. So please understand, we have naturally this whole science, right? The whole world. Naturally, we have some signals where we are supposed to process them, understand the environment, understand the systems. Similarly, other biological signals is brain waves. We were discussing about how a brain will give some signals, brain functional signals, right? Electroencephalogram, EEG. Then your muscles will generate a signals, what is called electromyogram. Your blood pressure changes, right? That is a signal called systolic, diastolic. Your blood oxygen levels is not same. The amount of oxygen you are taking, you are breathing, your blood oxygen is not same. If you don't breathe properly, then your oxygen in the blood is not same. Then maybe you may feel weak, so you should breathe properly. That is one of the important aspect of meditation center. As I told you, it is not about religious, it is about spiritual. Okay, so that's the reason I said meditation is all about breathing practice, right? You need to feel energetic, stress levels are low. So how to do the breathing properly? 99% people doesn't understand how to breathe. So your blood oxygen is not same. Okay, anyhow. So that's called the signals which come from the blood oxygen is called SpO2 levels. So the platforms which you can choose while doing this, as I said, it is not about computer. Okay, we are building whatever you see these PCBs, printed circuit boards, the components. These are all we design on our own at Wellanki at Mumbai Center. We design them, we fabricate, we manufacture, called application specific systems. This is our job. This is our business. Means we make computers, but it's not computer. It is computerization, because all applications require some sort of a automation, some sort of a smartness. In short, selection of the hardware, selection of the software, programming is all about our business. So that's what we train the students. We supply some products to the educational institutes as well as the industry. So platform, design and development. Then you have n number of examples, n number of applications, billions of uh, uh, investments are happening because everybody wants everything to be automized. smart, more smart. So the demand is lifelong. Okay, so uh, uh, I say that also study some self-learning, understand being a science student nowadays, right? I'm sure you are having applied science right from seventh standard. People are teaching because of these competitive exams. So again, go back to your schooling, or open those books, physics books, maths books, chemistry books, in short, science books. Please understand what is a signal, what is where they are coming from, these signals, right? What is the frequency of the signal, what is the wavelength of the signal, what is the amplitude of the signal, and from where they are coming from, what is the total spectrum of the signal, which signals are used where. Please, I'm not a science student, I'm not a science faculty, I'm not the right person to teach physics, chemistry, maths. I'm an engineer, so I expect you go back to schools, go back to open your books, read it once again. What is a signal? And again, these signals also, what is one-dimensional signal? What is two-dimensional signal? What is three-dimensional signal? I repeat, please understand what do you mean by amplitude of the signal? What do you mean by frequency of the signal? What do you mean by wavelength of the signal? From where the signals are coming from? What is the applications of these signals? And here also, what is the range of the spectrum band? Which band is used for what purpose? Where, right? And what is 1D, one dimensional, two dimensional, and three dimensional of the signals? Today, you know, applications in telecommunications, we use some frequency band. You know, no, for example, 2G, 3G, 4G, 5G, 6G. There is a frequency band. There are uh, military people uses some signals, telecommunication signals. Navigation in airports use a different kind of a signal. Military people uses a different kind of a signal, bandwidth, band of a signal. Police people use a different kind of frequency signal. Biomedical, I already mentioned ECG, EMG, EEG, they are a different kind of a signal. Agriculture have a different kind of a sensors and signals. And the environment, temperature, pressure, humidity, radiation, all these things, gases, tsunami, earthquakes, the nature is generating a different kind of a signals. So this is all about science. So science, I'm not the right person to teach. You go through some IIT NPTEL videos, extremely good videos, study it. Because if your concepts are clear, if you understand thoroughly science, then engineering is, we are there. We will help you out. Because applications of the science is engineering. Science I cannot teach. Science is your schooling, your college. Engineering I can teach, we can teach. That's the purpose of the center. So I repeat once again, do your homework. Again, we are there to help you out. How to select a CPU, how to select a programming language called compiler, how to write a program, how to design a product, how to convert that product into business models. We are there. All right. So and we already said these are all becoming products called wearable devices. Right. Maybe several years back also, I had developed one product for where you can wear it to your body called ECG using Bluetooth communication. In 2003, I was invited to Washington, D.C., and we are awarded world's topmost, entire world. We stood in top 10 position. Honorary award was given. But then one mistake we did that time is we are not aware of the commercialization. We didn't do the patenting. So we were happy, we got award, it's published, everything is okay. We came back. We we didn't bother about what we have done invention that time. But today you see the Fitbit, smartwatches, So many companies have done these wearable devices. It has become a billion-dollar industry. If we would have patented that day in 2003, I'm sure I'm also become a billionaire. It's like that. Because once you patent your design, other people cannot manufacture that. They have to buy your design, then only they can manufacture. So it's okay. I mean, things. In India, we have a system of let noble thoughts from every side. Means we educate the people. We say that why do you want to make a copyright? Everybody should know. Since we are also in education last 30 years, we never thought of doing the patents. But however, if you want to progress, your society wants to progress, your country wants to progress, patents means protecting your copyrights also has become important. Otherwise, we only give knowledge and we think that everybody should progress and develop. But then we are still a developing nation, and the people who have done the patenting, they have become rich countries, developed nations. So I think it's also important. You also should protect your copyrights through patents, your designs, right? So I said that what do you mean by computerization of the objects? You can see these are all the applications where the software and hardware is there, but it's a not like a standard computer. What is standard computer? You have a ASCII keyboard, LCD monitor, hard disk is there, power supply will be there, SMPS power supply, motherboard will be there, daughter board will be there, mouse will be there. So this is a standard computer. But in these devices also there is a CPU, there is a memory, there is a program, there are inputs, there are outputs, there are sensors, but it is not standard system. It looks differently. Some people doesn't use keyboard, some people doesn't use monitor. They may be having LEDs, they may be having LCDs, they may be having some speaker, buzzers, like that, but application specific. So humans have natural sensors, right? But we expect these things to be done electronically, right? Equivalent, whatever the humans are having, naturally God given things, biological things. We want them to be represented electronically by using some semiconductor devices like resistors, capacitors, right? Inductors, ICs. So we make equivalent for temperature. There is equivalent semiconductor device for alcohol detection, for radiation detection, displacement, everything, some electrical equivalence of some circuit is there. That is called sensor. What is the sensor is doing? Sensor is doing converting physical parameter into electrical signal. Okay, physical parameter. What is physical parameter? Temperature, pressure, humidity, radiation. These are all physical phenomena. But that I want in terms of a signal. That's why I said go back to physics. I want a signal first, right? Something is naturally changing. Temperature is changing, but I want a signal, 1D signal, 2D signal, 3D signal, whatever. I want in terms of signal. Once I get the signal, in the next session, I will tell you how to convert the signal into a number form, right? Because see, CPU understand only numbers, zeros and ones. CPU doesn't understand the signal where amplitude is continuously changing, frequency is changing. All these things are changing, but CPU understand either 0 or 1, binary. So that is my, in one of the next sessions, I will explain you how to convert the signals into binary numbers. Okay, so in short, our system, our application specific system looks like this. Here also it's like a computer. You can say inputs are there, outputs are there, memory is there, CPU is there. We are also doing the same thing. So it's a computer. Absolutely no difference. We also have a program. Everything is same, but we do not have hard disk. We do not have keyboard. We do not have display. Means ASCII keyboard, display. Something else will definitely will be there. That is what meaning of computerization of the objects. And one of the application is a robot. So the next session is we will be using a programming language to program this system, not a computer, a robot, a, a hardware, some CPU is there, some memory is there, by using visual language, means graphics. We topmost level we use in the first course. In the second course, we use some other uh, programming languages of high level language, not visual language. So how do we write the program? We use the computer. We type the program naturally, right? That's how we write. Or if you have a programs in your pen drive or in CD or some other way, we feed the programs. But then in our course, the programs are not executed on the computer. They are not executed. We transfer the program from the computer to a hardware. So we will give some hardware, some robotic hardware, some IoT hardware. You have to load it in this board because our programs are specially designed for a specific target, specific CPU, not the CPU which is used in computer, something else, different. Thousands of CPUs are there in the market. So that's why what we always call as a application specific. And then we generate the signals like microphones, speakers, right, and so on. Okay, so please understand, whatever we do it in the computer programming, we are also doing the same thing like editor, compiler, assembler. Finally, it generates a machine language called binary. Only thing is, in computer, programs are executed in computer. In our case, the programs are executed on a specially designed hardware, and that hardware we are designing. Okay, this is how it looks like. We type the program on the computer, but we don't execute the program on the computer. We design our own system, which is having our own CPU, our own inputs, our own outputs, our own sensors, and we transfer the program from the computer to that specific target device, and we test it. Where it is testing? On the device, physically, on a robot, on an IoT product, like that. So this is called application specific system or minimum system. All right, so that's all from my side for this session, just to understand what is the computerization of the objects, and then maybe I hope you understand this, my language, what I am talking. Slowly, we will go to the programming language in the next session. These videos I'm uploading also session by session on the YouTube. So the first video I recommend, this video I spoken in English about the significance of um, these robots and applications of the robots. However, henceforth I will be presenting speaking only in English because finally, your programmings are in English, so you need to understand also in English. It's not that I cannot speak, but you should be comfortable. And about Go Green, Mumbai and Wellanki, I spoken in this video what facilities we are having. You can refer this video. Thank you.